For our existence, oxygen is one of the most essential elements in our atmosphere. Beside carbon, nitrogen, sulfur, and other inorganic elements, there are many important atoms and molecules present on our planet Earth that makes this planet perfectly suitable for life. But beside their importance, they are not only responsible for the global warming on Earth, but they are having highly damaging effects on other planets and stars. I know you may be astonished to know how this could happen, but stay tuned to Gateway to Knowledge to know how the Earth's oxygen has rusted the moon for billions of years. To the surprise of many planetary scientists, they have found that the oxidized iron mineral hematite has been discovered at high altitudes on the moon. Iron is highly reactive with oxygen, forming reddish rust commonly seen on Earth. The lunar surface and the interior, however, are virtually devoid of oxygen. So, pristine metallic iron is prevalent on the moon, and highly oxidized iron has not been confirmed in samples returned from the Apollo missions. In addition, hydrogen in solar wind blasts the lunar surface, which acts in opposition to the oxidation. So, the presence of highly oxidized iron bearing minerals such as hematite on the surface of the moon is an unexpected discovery. This hypothesis states that the lunar hematite is formed through oxidation of lunar surface iron by the oxygen from the Earth's upper atmosphere that has been continuously blown to the lunar surface by solar wind when the moon is in Earth's magnetotail during the past several billion years. To make this discovery possible, the team of scientists analyzed the hyperspectral reflectance data acquired by the Moon Mineralogy Mapper M3, which was actually designed by the NASA's Jet Propulsion Laboratory on the India's Chandrayaan Mission 1. When they examined the M3 data at the polar regions, they found some spectral features and patterns which were different from those they saw at the lower latitudes or the Apollo samples. The scientists became more curious to know whether it is possible that there are water rock reactions on the moon. After many months of investigation, they figured out that they were actually the signatures of hematite. The team found the locations where hematite is present are strongly correlated with water content at high altitude, and they are more concentrated on the near side, which always faces the earth. More hematite on the lunar near side facing the earth suggested that it may be related to the earth. This reminds of a magnificent discovery by the Japanese mission that oxygen from the Earth's upper atmosphere can be blown to the lunar surface by solar wind when the moon is in the Earth's magnetotail. So, Earth's atmospheric oxygen could be the major oxidant to produce hematite. Water and interplanetary dust impact may also have played critical roles. Interestingly, hematite is not absolutely absent from the far side of the moon where Earth's oxygen may have never reached, although much fewer exposures were seen. The tiny amount of water, which was less than 0.1% observed at the lunar high altitudes, may have been substantially involved in the hematite formation process on the lunar far side, which has important implications for interpreting the observed hematite on some water-poor S-type asteroids. This discovery will reshape our knowledge about the moon's polar region, and Earth has played an important role on the evolution of the moon's surface. The researchers team hopes that the NASA's Artemis mission can return hematite samples from the polar regions. The chemical signature of those samples can confirm their hypothesis whether the lunar hematite is oxidized by the Earth's oxygen and may help to reveal the evolution of Earth's atmosphere in the past billion of years. So that was all from my side. If you enjoyed my today's video, then do like and subscribe to my channel. Until next time, stay shiny, stay healthy.